So let us solve one more question of discrete Z transform. Here we have taken one discrete time sequence x of n equal to 1, 3, 5, 6, 5, 2, and the value at origin is 6. Now in this discrete time sequence you can see we have some finite values on the left hand side of the origin also and on the right hand side also. So how to solve such type of questions of Z transform? Let us see. Previously we have already solved two questions. The first one is for right hand sequence and the second one is for the left hand sequence. This particular sequence is called both side sequence, and this question is also comes in examination of 5 to 6 marks. Solution. First write down the formula. Z transform of x of n is equal to x of z, which is equal to summation n is equal to minus infinite to infinite x of n z to the power minus n. One thing you always remember, that the time domain sequence is always written in lowercase and the frequency domain sequence representation is always in uppercase. So this one will be small x, this one will be capital X. Now if this value is the value at origin, then this position is -1 position, this is -2 position, and this is -3 position. This is first position and this is the second position. Or you can say our limits of the discrete time sequence starts from -3 and it ends at 2. Now one more thing, this value is small x of 0, this is x of -1, this is x of -2, this is x of -3, and this value is x of 1, this value is x of 2. So Z transform of x of n is equal to summation n is equal to -3 to 2 x of n z to the power minus n. Now put the values of n. X of -3 z to the power +3, x of -2 z to the power +2, x of -1 z to the power +1, x of 0 z to the power 0, x of 1 z to the power -1, x of 2 z to the power -2. Now put the values of x of -3, x of -2, x of -1, x of 0, x of 1, and x of 2. Now x of -3, the value is 1. 1 into z to the power +3, 3 into z to the power +2, then 5 into z to the power +1, then 6 z to the power 0 equal to 1, then 5 z inverse, then 2 z to the power -2. So this is the Z transform of the discrete time sequence. Now you can see in this Z transform we have positive power of Z also. We have positive power of Z as well as the negative power of Z also. Now we need to plot the region of convergence. Draw the Z plane. This axis is real Z and this axis is imaginary Z. Draw a infinite hypothetical rectangular box, minus infinite, and this one is infinite. This one is 0. Now look at here. We need to find out some values for which x of z converges, or you can say x of z attains a finite value. So let us put some values. If z is equal to infinite, then the whole sequence will be infinite. So we can say for z is equal to infinite, x of z always diverges. For z is equal to 0, this is 5 by z, which is always infinite. Again, for z is equal to 0, x of z is always diverges. Take some other values. For z is equal to, let 1. This is 1, this is 3 into 1, this is 5 into 1, this is 5, this is 2. So for z is equal to all other values, x of z attains a finite value always. So you can say the region of convergence for this Z transform is entire Z plane except Z is equal to 0 and Z is equal to infinite. So region of convergence is entire Z plane except Z is equal to 0 and infinite. So in this way, you can determine the Z transform and region of convergence for a discrete time sequence, or you can say both side sequence, or a finite duration discrete time sequence. Now one more thing, we have seen here for a both side sequence, this power of Z is always equal to positive and negative. Okay, thank you.